In this fifth and final lesson, we're going to look at factoring some more binomials. Right, and we did this at the very beginning. We pulled out the greatest common factor. So if I look at 144s squared and 196, I know that they're both even. And a little bit more investigating, I know that they are both divisible by 4. So if I factor out a 4 from 144s squared, that leaves me with 36s squared. And if I factor out a 4 from the 196, that leaves me with negative 49. Now, I can't stop here because it tells me to factor completely. And all of these problems you're going to be asked to factor completely. And what I have here is factorable. And here's how you can tell if it's factorable. 36 is a perfect square. And s squared is a perfect square. 49 is also a perfect square. And this is subtraction. So this is called the difference of two squares. It's a very easy way to factor. There's not going to be a whole lot of a process or long thing that you have to write out. We're going to jump straight from here to my final answer. So I have that 4 that's still on the outside. And the way I write my answer is it's going to be 2 sets of parentheses. And I take the square root of 36, which is 6, and that goes at the beginning of both sets of parentheses. I take the square root of s squared, and that goes with the 6. Now, for this to be minus, I need one of these sets of parentheses to have a plus and one to have a minus. And then I take and do the same thing here. The square root of 49 is 7. So the 7 goes in both sets of parentheses. Now you might be kind of confused on how I knew all of this. So let's talk about if we had this problem a couple chapters ago last semester and we were asked to multiply it out. Well, I would take 6s times 6s and get 36s. And then I take 6s and multiply it by the negative 7, so that's negative 42s. And then I do the inside, which gives me positive 42s. And then I do the last, which gives me this negative 49. Now, I have this extra stuff here, but this is a negative 42s, and this is a positive 42s, so those cancel, and that's where the 36s and the negative 49 came from up here. So this works because these are what we called conjugates. And if this is the problem that you have, you would enter all of it, including that 4 out front. Don't turn around and multiply it out unless you just want to double check. But that will get you back to the original problem. This right here is your final answer. And that's where you can stop unless you want to check. For this section and future math classes, it might be beneficial for you to start remembering some of the perfect squares. Now, I know that 121 is 11 squared, so the only factors of 121 are 1, 11, and 121. And 196 is not divisible by 11. So they don't have anything in common, but 196 is also a perfect square, and that one's 14 squared. So since they don't have anything in common, I can go to my 2 sets of parentheses, and I take the square root of this, which is going to be 11a, and put that at the beginning of both sets. I take 196 and the square root of that, which is 14, put that at the end, and then 1 becomes plus and 1 becomes minus. And that's your final answer, as long as this is subtraction and they're both perfect squares. Again, this problem we're going to do the same thing. except we have a perfect square plus a perfect square. And when we have a plus sign in here, the process is going to be the same, except we have to now include imaginary numbers, right? It may sound complicated because before when we did imaginary numbers, a lot of people struggled with it, but it's really just a matter of putting an I into the same process that we've been doing. So I'm going to go with my two sets of parentheses, and I have s squared. So square root of that is s, that goes in both sets of parentheses. I have 36, so that's going to be 6 in both sets of parentheses. Still going to be 1 plus, 1 minus. The only difference is because this is a plus, I need to include an I with this 6. And here's why. If we turn around and FOIL, and again, this is going to be your final answer. This is what you enter here. But if we turn around and FOIL it, s times s is s squared. Here I get minus 6si, and then here I get positive 6si, which those are going to cancel. And I have positive 6 times negative 6, which is negative 36. But now with this I get I squared. And if you remember, the I squared changes this to be plus, and that disappears. So that's where we get the s squared plus 36. The only time you have imaginary numbers is when this is plus. Other than that, you separate it into the two, and you don't have to worry about imaginary numbers. Hopefully you've learned a lot through this chapter on factoring. If you have any questions, ask me in class.